What if you could be blindfolded, dropped in the middle of an ocean, and still find your way back to the exact house where you were born, using only your nose? Picture this. A salmon born in a cold freshwater stream no wider than a country road. It spends its first months there, then begins an impossible journey downstream to the vast, trackless ocean. For years, it travels thousands of miles through featureless blue, feeding and growing. Then something clicks. An internal clock rings, and it begins the most precise navigation feat in the animal kingdom, the journey home. Not to a general region, not to a familiar coastline, but to the exact gravel bed where its life began. Scientists once thought they used the sun or the stars or Earth's magnetic field, but the real answer is far more intimate. They follow a scent, a chemical signature imprinted in their memory from the moment they hatched. But how does a fish remember a smell across years and continents? And why would evolution design such a precise and perilous homing system? Let's start at the beginning. The nursery. A salmon's life begins in the gravel of a shallow stream. The water is cold, clear, and most importantly, it carries a unique chemical identity. Every stream has its own mix of minerals, soil compounds, decaying plants, and microbial life. This creates a scent profile as distinct as a fingerprint. While the young salmon, called a fry, is growing in this stream, its olfactory system, the part of the brain responsible for smell, is actively recording this chemical signature. It's not a conscious memory. It's a deep neurological imprint, like a song you can't forget. This is the first step in a process scientists call olfactory imprinting. The salmon isn't just learning a smell. It's wiring its brain to recognize this specific combination of chemicals as home. After a period of months, the young salmon, now called a smolt, undergoes a dramatic physical change. It becomes capable of surviving in saltwater. It begins its journey downstream, leaving the familiar scent of home behind. For the next 1 to 5 years, it will live in the open ocean, traveling vast distances, feeding and avoiding predators. All the while, that initial scent memory lies dormant. It's a saved coordinate in the internal GPS of its mind. Then, triggered by maturity, changes in day length, or water temperature, the salmon turns toward land. This is where the real magic begins. It's not a straight shot. The journey happens in stages, and at each stage, the salmon uses a different tool from its navigational toolkit. The first leg is the open ocean. Here, evidence suggests salmon use the Earth's magnetic field like a map. They can sense minute variations in the planet's magnetism, which gives them a general sense of latitude and longitude, a rough heading toward the correct coastline. Think of it as typing a city name into your GPS. You're in the right country, but you're still hundreds of miles from your street. As the salmon approaches the coast, it switches tools. It begins to sample the water, tasting the complex cocktail of scents carried from the land by rivers. Each major river system has a broad, general scent. The salmon is searching for the one that matches the large-scale memory of its natal river system. Once it enters the mouth of the correct river, the final and most precise phase of the journey begins. Now, it's navigating entirely by smell. It's no longer looking for a city, it's looking for a specific street, then a specific house. The salmon swims upstream, constantly testing the water. It's following a scent gradient. The concentration of that unique chemical fingerprint gets stronger the closer it gets to the source. It's literally swimming up the trail of its own childhood. It will bypass dozens of identical-looking streams because their chemical signature is wrong. Only the one that matches the deep, primal imprint in its brain will trigger the final turn. This explains why you can have two streams emptying into the same river, just 100 yards apart, and one will be full of returning salmon while the other is empty. They are following an invisible map written in molecules. This incredible ability comes at a cost. The journey upstream is a gauntlet. It requires immense physical energy. The salmon stops eating, living entirely off its fat reserves. It fights strong currents, leaps up waterfalls, and dodges predators like bears and eagles. Its body changes color. For many, it's a one-way trip. They spawn and then die, their bodies becoming nutrients for the very stream that raised them. So why go through all this? Why not just spawn in any convenient stream? The answer is evolutionary perfection. By returning to their precise birthplace, salmon are almost guaranteed that the environment is suitable for their offspring. They are, in effect, proven survivors of that specific location. Their genes are fine-tuned for that stream's particular conditions, its temperature, its flow, its predators. This homing instinct prevents overcrowding in random streams and ensures the survival of locally adapted lineages. It's a brutal, beautiful, and highly effective strategy that has allowed salmon to thrive for millions of years. The salmon's journey is more than a biological wonder. It's a powerful reminder of the invisible connections that bind an animal to its home. A connection so strong it can guide a creature across an ocean and back to the very stones where it began. It's a story written not in maps or stars, but in water and memory. What other animal migration amazes you the most? Let me know in the comments, and your pick could be the focus of our next deep dive.